Okay, so I need for you guys to flip your paper back to the front. Okay, back to the front. And let's look at example 1. Okay? For example 1, you can see that we have a right triangle. How do we justify this a right triangle? Many times when you take the test, they will not tell you this is a right angle. But anytime you have a tangent and a radius that meet at the point of tangency, once again, when you have a tangent and a radius, and they share the point of tangency, the point of tangency is one of their endpoints, then those two segments are perpendicular to each other. They form a right angle. So since this angle is a right angle, we have a right triangle. And notice we have measures for 2 of the sides of the right triangle, but we are asked to solve for the third side measure. How do we do that? We use Pythagorean theorem, okay? So Pythagorean theorem is, let's write this on your paper, a squared plus b squared is equal to c squared. And when we do this, we know that a and b are the legs. It is the leg squared plus the other leg squared equal to the hypotenuse squared, okay? So for A and B. So for one of the sides that meet, and the legs are always the 2 sides that meet to form the right angle, okay? So for one of the sides that meet to form the right angle is R. So let's put R squared for A. And then the other leg has a measure of 48. So B is 48, let's square it. And then the hypotenuse is always the longest side, the one across from the right angle. It is 50. Okay, so let's plug our measures where they need to go. So now we need to simplify what we have here. So you need your calculators, all of you. Plug this in as I do it, okay? So we keep the R squared for now. And put in the calculator 48 squared. And we get 2,304. And then we put 50 into our calculator and square it, and we get 2,500, okay? So, for the number by itself, leave it. For the other side, which one of these is like that number over there? We want to move the like term to the side with it. So we want to move the 2,304 by subtracting 2,304 from both sides, okay? All right, so that counts out 2,304 and leave R squared isolated. So on the other side, what is 2,500 minus 2,304? Plug that into your calculator, and we all should get 196. Now let's take the square root of both sides. The square root of 196, and that leaves 14. So R is equal to both the positive and negative of 14. And that's our answers. Okay, very simple. Let's do another one together. Let's do 2 more. Then you guys should have plenty of examples that you can look back at and rework to understand how to work problems like these. Okay, so we did example 2 already because we had 2 tangents. When you have 2 tangents, then those measures are congruent, so we set those equal. But here we have 1 tangent to a circle. But this point of tangency is also an endpoint of a radius, so these 2 segments are perpendicular. You have a right triangle. You know the measures for 2 of the sides. You got to solve for the third side. So we plug into, once again, Pythagorean theorem. A squared plus b squared equals c squared. Where A and B represent the measures for the legs. All right, so for one of the legs, it is R, plug it in, plus the other leg is 28 units. So plug that in, squared. And now we are also given the hypotenuse. The hypotenuse is the longest side, and it has a measure of 35 units. So plug that in. So now we need to solve for R. So we bring down the R squared. Let's find out what 28 squared is. And then I need you to come closer. Get up and come closer so they can see this. Okay? And then we want to take 35 and square it. Don't play with me, Landon. And that gives us 1,225. Okay? So now we want to subtract 784 from both sides of the equation. That leaves R squared on the left. It cancels out the 784 on the left as well. So 1,225 minus 784, that leaves 441. So let's take the square root of both sides. And that gives us 21. Both the positive and negative of 21. Are there any questions? So I want to do one more example problem with you, and then I feel like you have enough information given so you can successfully complete the back side of the worksheet, okay? All right, so let's do problem number 4. Problem 4, we want to use the Pythagorean theorem. A squared plus b squared is equal to c squared. All right, so these are your two legs because they meet to form the right angle. So one leg is represented by r. The other leg is 70 squared. And then the hypotenuse has a measure of 74 feet. And once again, we know this is a hypotenuse measure because it should be the largest measure. When you solve for r, the measure will make sense if it's smaller than 74, okay? All right, so now let's simplify what we have here, r squared plus. But you know what, I've been squaring the 70. You don't really have to do that right now. But if you want to, you can go ahead and simplify it that way. But since we've been doing that, let's go ahead and continue to do so. So 70 squared is 4,900. But let's see what 74 squared is. 5,476. Let's move the 4,900 to the other side to get it with this like term. So it cancels on the left, and that leaves r squared. So 5,476 minus 4,900 leaves 576. To undo this square, we take the square root. Do that to both sides. So r is equivalent to the positive negative of 24. And we are through. Are there any questions? Okay. All right, so I want you to continue to complete the problems on this worksheet. You have some problems on the back to work on, so do those. And then I should have an answer key available. You can check with Mrs. Bundy to see what the answers are if you're doing the problems correct. Okay. So please work on this. Go back and review the concept you were taught on Monday and Tuesday because you will have a quiz tomorrow. So please practice. Complete all your work. I left some keys for you to check your work and make sure you're doing it properly. And hopefully everybody will do well tomorrow on your quiz. Good luck. All right, see you next week.